All right, good morning, everyone. Sorry about the delay. So, good morning, everyone. So my name is Dr. Arjuna Madanayaka. I'm Professor of Electrical and Computer Engineering at FIU. So I will be teaching signals and systems in fall, right? I typically teach signals and systems and communications to FIU undergraduates like you. Let's get started. Give me a second. Make sure everybody's logged in. All right, good. So I'm Arjuna. You can call me Dr. Arjuna or Dr. Madanayaki, that's fine. I have been at FIU for now 7 years. I mainly do research in signal processing, digital design, and IC design, that kind of stuff, hardware stuff, wireless communications. And I use signals and systems every day. My graduate students are there, so very soon I will introduce everybody. But just to get started, I think we should begin with a very short icebreaker before we get into the details of the course. So I want everyone to feel welcome. This is a very interactive course. I want everyone to participate in the class discussions, not be just a passive listener. I want you to raise your hand or just even jump in and ask questions at any time. That's fine. And it has to be more of an active, kind of environment, right? Very friendly place. So there are no such thing as a stupid question. Any question is always welcome. And I'm always here to answer your questions and discuss stuff with you. Plus, we have 3 extremely bright PhD students who have volunteered their time. They're not getting paid for it. They are doing it for the goodness out of their heart to help me help you. Okay, so we have a very good team, super smart people to help you back over there. So Nilan and Ben and Jaime, 3 PhD students at FIU who specialize in this topic is available to you. Okay, so we'll share with you all the details of how to contact them, how to contact me as we go along. So first of all, I want to start with an icebreaker, introduce everybody, and then we'll get into the more details of the organizational structure of the course today. So the way I want to start is that I like to start slow and then I like to ramp up. Okay. So the first week, today we will be just going through the course structure, the course materials, how we are going to organize ourselves in the class, stuff like that, how we will evaluate you, what kind of projects that you might want to do. That basic stuff we'll go over today. On Thursday, I will have all of you actually come to my lab and we'll show you some of the things that we are doing so that you can, see what all this stuff is about before you get into the math part, right? Otherwise, I noticed that people are just, doing mathematics and theories and simulations, but they don't really have a feel of what this is about. So I think it's better we make a change. We first look at the real deal, and then we come back and look at the course material. So I think it makes more sense to do that. Okay. All right. So again, I'll go first. My name is Dr. Arjuna Madanayaka. I'm a faculty at FIU. What's that? Can you turn off sound, please? Right. So first of all, let's do a quick self intro. Just take a minute. Tell the class who you are, what your interests are, where you are in the program, or any other details, what you want to study, what you want to be in the future, whatever you want to share as a small icebreaker. So I'm not going to record that part. I'm just going to pause it. Okay. Give me a second to pause the recording. All right. So we are back. Can you turn off the sound, please? So let's look at how we will do the course. So the course is called Signals and Systems, as you well know. So let me. Oh, this is really. Let me see, why is that? All right, so the course is signals and systems, right? So the way I teach this course is that I will go through the lecture stuff, the material in class. And for those of you who are taking it online, all the information will be posted on Canvas. But there is a very good series of course notes and lectures from MIT from a very well-known professor called Alan Oppenheim. Right. So I'm not using an expensive textbook in the course. I want you to use the MIT Open Courseware because it makes no sense to spend $200 on a textbook when excellent quality material is available for free from MIT or somewhere else. So if you look at the syllabus, I have the link for the MIT Open Courseware link for the equivalent course at MIT. And that's got a set of lectures and a set of course notes and all the relevant background materials that you would need. So you don't have to buy a textbook. But having said that, all of the topics that we need to cover in the course, I will go through in class here, right? So the MIT Open Courseware is just a reference for you to go back and read additional things. So if you don't follow something, you can go and read that as a textbook. But most of the, or almost all the things that we need to learn, I will go through in class with you as part of the lecture, right? So the way I do it is that I split the course into basically two sections. The first few weeks or maybe the first half, a little bit more than that maybe, it's about learning the theoretical parts and learning the foundational math of signals and systems that we will do in the class through with me. Then the second part will be more like a project where you will do some simulation, some design work as part of a student project, typically using MATLAB, right? So we will teach you the basics of using MATLAB to write the simulation code as part of the lectures. And we will get you up into a point where you are good enough to actually do your project by yourself or as a team in the second half of the course. So it's very important that you actually learn the MATLAB stuff, especially if you are not familiar with MATLAB, in the first month or month and a half, so that you have a bunch of examples that are working that you can go back to and kind of draw upon to build up a bigger project later in the course. Okay. The course itself, typically in past years, I had a mix of closed book and open book exams. But this year, I'm going to change that. And the reason I'm going to change that is we have two sections in parallel. We have this section on campus and another section that's online. So in order to make sure I have a level playing field and everybody's treated fairly, I decided I'm going to make all the exams open book and at home. Okay. So, well, not at home, but some of them could be here. But generally, you don't have to memorize stuff. You can have your course notes and textbooks open. So that way, it's fair with the people who are taking stuff at home, right? Otherwise, they are going to look at the book anyway, and I cannot check, right? So both sections of the course will have the same evaluation metrics, same examination materials, same projects, same everything, and the same lectures. The only difference is that you are here talking to me and other people are at home for the online section. That's the only difference, right? So having said that, I don't want you to use ChatGPT or any other Gemini or any other AI stuff in the course because we are trying to teach you how to do it, not how AI to do it, right? So you can use AI in other parts of your life, just not this part of your life, okay? So no AI, no ChatGPT, no nothing. Old school manual, read the book, scratch your head and learn the material. That's what we need you to do. Super important. So you can use your notes, open book, read books, Google stuff, whatever, but you cannot throw stuff into ChatGPT and get answers out. That is not allowed in the course, okay? Even though it's open. Now, what else? So the way I organize it is that I want to have very fast turnaround in communications. So typically, if I send an email out through Canvas, many students don't check this email or they check it once a day or once a week. It's kind of too slow at the pace that we are going to be working on. So what I suggest is, in parallel to all the Canvas stuff, I'm going to have something like a WhatsApp group that will be immediate. And if you want to get notified of things that are happening the moment it happens, then you can join the WhatsApp group optional, right? You don't have to join it if you don't want to, but we are going to have it anyway. You're welcome to join it, but there won't be anything in the WhatsApp group that's not already on Canvas. It's just a copy, okay? But it's just faster. So I highly recommend it. I've done it in the past, and it has been very successful to keep students and the TAs informed about any updates, things like that. If I'm stuck in traffic and I'm going to be 10 minutes late, I'm going to put it on the WhatsApp group, and then you'll know, okay, he's on his way. Okay, things like that. So let's first do that part, and then we will proceed. All right, so let's look at a simple example of some basic mathematics that we might need just to get started, right? So I'll slowly ramp up with the actual theories and stuff like that once we get into it. But I want to start with something like a quick review with a bunch of simple problems that you will try yourself. So let's try some basic math, the kind of stuff that you might need. For example, so let's say you have a function. Let's say I'm going to define x of t as a function of time in such a way so that x is the variable, right? That defines the function. Function with time t. So time t is called the independent variable. So typically time is real valued. It occupies all positive values in the real line. So we can write time as a subset like this, where this is the set of real numbers. So in signals and systems, we have all kinds of functions and signal sequences. Some of them are defined as mathematical expressions, some of them are not. But the simplest possible example of a function in signals and systems is a sinusoidal wave, right? So we can write, for example, x of t as a, let's say, sine omega t plus phi. So let's take a moment to understand what are the different quantities that we have talked about here. So we have defined a so-called sinusoidal function, and that function is described in terms of 3 parameters. What are the 3 parameters? The first parameter is A. This is called the amplitude. And then we have omega, that's called the frequency, actual circular frequency. And then we have phi, which is called a phase. So typically, the circular frequency is described in terms of the regular frequency, right? So we can write omega is equal to 2 pi f, where omega is the circular frequency. and this is the time frequency measured in hertz. Yeah. Angular frequency and circular frequency mean the same thing. Yeah. So typically you can have a function, right? So sine starts with 0 when the independent variable is 0. So something like this, right? So this amplitude is A. This is called the period. So typically F is equal to 1 over T. This is T. In this case, phase is equal to 0. So we know that sine crosses 0 when the axis is equal to multiples of pi, right? So can you find what are the times in terms of t? So let's call this one t1 and this is t2 or t dash, double dash. So can you find t dash and t double dash in terms of let's say omega? So we know that the first one, right? Omega should be equal to pi, right? So that is similarly is equal to 2 pi. So this cancels off. So can you do x of t is equal to a cos omega t plus phi. So take phi equals 0, plot an example